How to graph y equals the tangent of x using the unit circle values with proper vocabulary. This is part of the Family of Functions series. You will need paper and a straight edge, or you can download this trig graph paper. Press pause as needed anytime. Graph y equals the tangent of x. We are proceeding with the assumption that students know the unit circle values for the tangent function, its domain and range, and where the tangent function is undefined. We'll plot the tangent function from x equals negative pi over 2 to x equals 2 pi. Pause is needed. First, we'll draw dashed vertical lines where the tangent is undefined. Recall, since tangent is the sine divided by the cosine, the tangent is undefined when the denominator is 0. That is, when the cosine is 0. So this occurs at pi over 2, 3 pi over 2. So we'll put dashed vertical lines there. But the tangent is undefined at any odd multiple of pi over 2, which will also include negative 1 pi over 2. Next, we're going to plot points from the first quadrant with a table. Pause to complete the table. These are the values that you should just know. We are going to need decimal approximations for these irrational numbers. So I used a calculator, actually 2 different calculators, to get the answers and rounded them to their nearest hundredth. Pause is needed. So we're going to plot the points, starting with the origin, then over 2 pi over 12 and up about 0.6. Each one of these markings is pi over 12, by the way. Then over 3 pi over 12, which is pi over 4, and up 1. Over 4 pi over 12, which is pi over 3, and up about 1.73. And of course at pi over 2 it's undefined. So we're going to look at values of x that are close to 0 but positive. See what that curve looks like right around in here. And so I picked these numbers: a tenth, 2/10, and then 1 pi over 12. So again, I'm using a calculator to evaluate those. The tangent of, and make sure you're in radian mode here. Tangent of 0.1 is about 0.1, about 0.2, about 0.3. So I'm going to go ahead and plot these points. So 1/10, 1/10, 2/10, 2/10, and pi over 12 about 3/10. Because I wanted to get an idea of how that curve looked like right here. Okay. The other place I want to look is at values of x that are close to pi over 2, but strictly less than pi over 2, and we're talking about these x values right here. So here's pi over 2 to several decimal places. A number that's close to pi over 2 but less than it would be like 1.5. So I'll go ahead and take the tangent of that and get about 14.1. Getting a little closer, I'll go with 1.57 for x. And the tangent of that is, whoa, 1255.77 approximately. And then 1.5707 is less than pi over 2, but pretty close to it, closer to it than the previous two. And when I take the tangent of that, it's 10,000 something. So from the table below, it's clear that as x gets closer and closer to pi over 2, the tangent of x is getting, wait for it, larger and larger. So let's go ahead and connect the points. And I'm going to extend that asymptote just for effect. That is, x gets closer and closer, this thing goes up higher, faster and faster. So let's go ahead and look at this a little bit closer. Let's analyze what's happening to the graph of y equals tangent of x as x gets close to or approaches the number pi over 2, which we're talking about right here. But it's from the left side, okay? Because we could also approach pi over 2 from the right side. We're going to use some shorthand notation that mathematicians have developed. X, arrow, pi over 2, and then almost as an exponent, a negative sign. That symbol there means that x is getting very close to pi over 2 from the left. Another way to word it is that x is approaching pi over 2, but strictly smaller than pi over 2, or from the negative side. Pause is needed. So let's analyze what is happening to the graph of y equals tangent x as x approaches pi over 2, but from the negative side here. Tangent is sine divided by cosine, so we're going to look at both the sine and the cosine graphs. On the sine graph, as x gets closer and closer to pi over 2 from the negative or left side, the sine is getting closer and closer to the value of 1. So for example, let's say the sine of x is 0.999. That's pretty close to 1. As x approaches pi over 2 from the negative or left side, the cosine is getting very, very close to 0, but positive. Notice it's a positive. So cosine of x could be about 0.001. So dividing those two numbers, we're going to get 999. So as x gets very close, the sine gets close to 1, the cosine gets close to 0, this number is getting really, really big. But we could try it again with maybe 0.9999, and then cosine is about this, and when we divide those two numbers, we're getting huge number, huge number. So for the tangent, as x approaches pi over 2 from the negative or left side, we say that the tangent increases without bound. When this happens, the function is increasing without bound, meaning it's getting larger and larger, faster and faster, the closer it gets to this pi over 2, but from the left-hand side or the negative side. The line x equals pi over 2 is called a vertical asymptote, kind of like a boundary line. Pause is needed. Second, we need to do the second quadrant with the table. And so these are the values that we should know from the second quadrant. Pause to complete the table. So these are the values you should get, and then I'll also put in the approximations. Notice in the second quadrant the tangent is a negative number, except for when it's undefined or 0. Plot the points. Pi over 2, it's undefined, but at 2 pi over 3, which would be 8 pi over 12, 6 12, 7 12, 8 pi over 12, down to about negative 1 3/4. At 3 pi over 4, 9 pi over 12, it's negative 1 exactly. At 10 pi over 12, it's about negative 0.6. And at pi, it is exactly 0. So using similar logic as we did in the first quadrant to get this curved graph this way, we're going to go ahead and connect the points. And it's going to be a very similar looking curve, except it's going to go down to the left like this instead of up to the right. But let's look at what's happening to the graph as x is close to pi over 2, but in this case from the right side. The shorthand notation for this is arrow pi over 2 with a plus sign for the exponent. It's read x gets close to pi over 2 from the right, or you can say it's x approaches pi over 2 but larger, or from the positive side. So as x approaches pi over 2 from the positive side, the tangent is, we're going to say, decreasing without bound, getting really, really small, but the number is negative. Large in size, but negative in direction. Pause is needed. Recall that the period of the tangent function is pi, and we've graphed a period, because from 0 to pi is a width of pi. So we've already graphed it. We just need to now duplicate the graph. So I've taken this that's in the first quadrant, and I'm duplicating it now in the third quadrant. Pi away. And this in the second quadrant will now go back to the fourth quadrant in the negative direction, that is. But I'll also take this second quadrant and go to the fourth quadrant in the positive direction and duplicate that. So this is the graph of y equals tangent of x, a beautiful looking curve with the asymptotes shown. The domain, it looks like it's all real numbers, except where the tangent is undefined. The tangent is undefined when the cosine function is 0, and this occurs at odd multiples of pi over 2. Negative 1 pi over 2, positive 1 pi over 2, positive 3 pi over 2. Now how do we write that with math symbols? Well, we use the set of all x such that x is a member of the real number system. However, x is not equal to the quantity of 2k plus 1, this is how we write odd numbers, times pi over 2, where k is an integer. So any odd multiple of pi over 2 is not allowed. That's how we write the domain. The range, well, looks like it goes on and on infinitely in both directions, all real numbers, so we write that as the range is all real numbers using the script r.